I think we stopped up to here. Am I right?
Yes.
So today we have to start this one. Am I right or not? Am I right?
Yes.
Okay. So my dear, today we are going to study how to get the time period for two cases. The first case, if you just attach the spring, attach the bobs on the spring, or attach any mass on the spring, when you just drag this mass to some certain level, when you leave, what will happen? It will be undergo simple harmonic motion. That means your spring will be moving here and there. Am I right? Left to right. Am I right?
Yes.
So in such a case, how to calculate the time period? So that is the information we are going to see from this slide. So here I'm going to use the Hooke's law because we already studied the formula F is equal to minus Kx, and we are just going to relate that formula with Newton's second law F is equal to ma, and when you just apply these things, we are going to get some information, and finally we are going to learn how we got this time period formula. That information I'm going to explain here. Okay, so please listen carefully. This is very, very important topic, and for sure some questions are there from this topic. Okay.
Okay.
Okay, what is new? What is Hooke's law? Could you please tell me what is Hooke's law? F which is equal to minus
Minus K.
Kx. Okay, and then if the spring will be moving here and there, it has some acceleration. Am I right?
Yes.
So I can relate that with Newton's second law, F is equal to ma. Now you can see here, my left hand side of these two equations are force. So I can equate this with this. Am I right? So if I just equate, what I will get? Ma, which is equal to minus Kx. So from this equation, I can easily find the acceleration of the mass. Am I right?
Yes.
Therefore, A, which is equal to minus K over M multiplied by X. Clear?
Yes, teacher.
Okay. Now what I'm going to do? I'm going to take this term and I'm going to make this equation to 0. So if you want to make this equation to 0, I have to bring this term to the left hand side. Am I right? When you bring this term to the left hand side, this negative becomes positive. So in such a way, what you will get? A plus K over M, which is equal to K over M multiplied by X, which is equal to 0. My dear, this is the equation for the simple harmonic motion for the given diagram. Which diagram? This diagram. Okay, understand?
Yes.
Yep, teacher.
Now this is the equation. For example, I am going to compare this equation with a standard equation for the simple harmonic motion. What is the standard equation? If you want to know the standard equation for the simple harmonic motion, standard equation for simple harmonic motion. This is the standard equation. I'm going to write the standard equation. I'm going to compare my equation with the standard equation. What is my standard equation? The standard equation is given as d square x over dt square plus omega square x, which is equal to 0. This is the standard equation. Now I am going to compare this equation with the standard equation. My dear, here I have the acceleration. Am I right?
Yes, teacher.
What is this? This is also an acceleration. You
This
already studied chapter
acceleration.
2.
Oh, no. Sorry,
Right?
velocity.
Maya,
Sorry, velocity.
my dear, how this becomes
Ah.
velocity? My dear, velocity which is equal to dx over dt. My acceleration which is equal to d square x over dt square. Am I right?
Yes.
Doctor,
So,
where is the velocity?
my
We
dear,
know
first of all,
acceleration equal to. Oh, yes. I got it. Sorry, I got it.
Because right now we are in 15th chapter. You know this basic concept in chapter number 2. Am I right?
Yes, you are right.
So if you
The double
if you
double.
if you differentiate the displacement equation one time, you will get the velocity. If you double time differentiate the displacement, you will get the acceleration. Am I right?
Yes.
Right.
So this is also my acceleration term. So you can just see the first equation. Here also I have the acceleration. Here also I have the acceleration. Now let's come for the second term. Second term, I have k over m, where k is the spring constant and m is the mass multiplied by x. And here what I have omega square multiplied by x. That means I can just have the same type of equation here. Am I right?
Yes.
So in this equation, how I can write my omega square, which is equal to k over m. Am I right or not? When you compare this k over m with this omega square, my omega square, which is equal to k over m. Am I right?
Yes, we delete the x with x. Yes.
Yes,
you're
because
right.
x, here also you have x, here also you have x, so I can just compare only the second term, because my first term is the acceleration here also my first term is the acceleration. My second term
Yes,
is
you're
some
right.
value with the x, here also I have omega square with the x. So I can compare this omega square with this k over m, so I can write like this. So now what I'm going to do, I'm going to take the square root on both left hand side and the right hand side. So what you'll get, my omega, which is equal to square root of k over m. Am I right?
Yes, you're right.
Brother, we studied the relations connecting the angular frequency and the linear frequency. Omega, which is equal to 2 pi f. We studied this equation. Am I right?
Yes, you're right.
So you can just say this is nothing but 2 pi over t also, because my frequency is 1 over t. So when I just substitute the 1 over t for the frequency, I will get omega, which is equal to 2 pi over t. Am I right?
Yes, you're right.
So what I'm going to do, I'm going to take this omega, I'm going to substitute here. If you substitute, what you will get? My 2 pi over t, which is equal to square root of k over m. Now I'm going to write the time period equation from this equation. So I'm going to rearrange this equation in terms of time period. Therefore, my time period equation becomes, how it will be becomes 2 pi over square root of k over m, which is equal to time period. If I just rearrange this equation, my time period, which is equal to 2 pi over m over k. Am I right?
Yes, you're right.
So you can just see this is my time period equation for when you are just going for this concept. So if you just see the equation, we will get the same equation here. Am I right?
Yes, teacher.
Yes, you're right.
So, brother, listen carefully. If you have the question from chapter number 15, please read the question very carefully. If the question is related with the bob, the mass is connected with the spring, and if you want to find the time period, then you have to use this time period formula, because in this chapter, we are going to have two formulas in terms of the time period. The first time period is for the spring with mass. The second period is for the simple pendulum. So please read the question very carefully. Clear? Understand?
Give us example, teacher. I
Idea?
example.
Okay, I will give you, inshallah. Don't worry. I will give you. After finish the chapter, then I will show you. Okay?
Okay.
Okay. Now, let's come for how to calculate the energy in simple harmonic motion. My dear, listen carefully. I am going to draw some diagram. Now you have to give the answer. We already studied this equation in our last chapters. That means in chapter number 7 and 8, we already studied this concept. I am going to draw the diagram. My dear, listen carefully. I have a spring. Connected one end to the wall and another end I connected with a mass. Right now, when I just attach the mass, this is my equilibrium position. Am I right? So I can just write this is my equilibrium position. Now I'm going to drag this mass downward direction. So what will happen? The spring will be elongated. Am I right?
Yes, you're right.
So your picture will be like this. Am I right or not? So this is my mass right now.
Yes.
Now, when I just leave this mass, what will happen? My spring will come to the equilibrium and then it will be going here. Am I right?
Yes, you're right.
So this is my displacement from the equilibrium to the bottom side, and this is my displacement from the top view. Am I right? So if you just see these things from this equation, how to calculate the energy equation? My dear, all the times your energy equation is depend upon the amplitude of the equation, because we already studied the wave equation. What is our wave equation? X of t, which is equal to xm cosine of omega t plus phi. Please memorize this equation, because this equation is very, very important for solving the problem. Now, if you just see this equation, your wave equation is entirely depend on the amplitude. Once the amplitude is more, your amplitude is depend on the energy. So we already studied the equation for the energy. The total energy, which is equal to potential energy plus kinetic energy. Am I right? Am I right or
Yes,
not?
potential. Yes, yes.
What is the potential energy for the spring body? We already studied this rule. What is the formula? Half k x square. Do you remember this formula?
Yes.
What is the formula for kinetic energy? Half mb square. Am I right?
Yes.
And what is the formula for the energy? Your energy formula is also related with the amplitude, so which is nothing but half k amplitude square. So please keep this information in your mind. Your amplitude is nothing but it's related with the energy, which is equal to the sum of potential energy plus sum of kinetic energy. Now you can see here, when the bob come here, your speed is your potential energy is maximum here in these two cases. Am I right? In these two cases, your potential energy becomes maximum. But in this case, when the object comes to the equilibrium position, your kinetic energy is maximum, your potential energy is zero. So again, we are going to use the same conservation of energy. We already studied in chapter number 7 and 8. So here the energy equation is given as half k xm square, which is equal to the sum of kinetic energy plus potential energy. Clear? Clear?
Clear, doctor.
Yeah.
Yes, teacher.
Okay.
Clear.
Now we are just coming for the last topic in this chapter. We already did this experiment in our lab, experiment number 10, simple pendulum. Am I right? My dear, do you remember this equation? We use this equation for our data analysis. T, which is equal to 2 pi over L over G, square root of L over G. Do you remember this equation? When you're squaring left hand side, right hand side, what you will get? T square, which is equal to 4 pi square L over G. Do you remember this equation?
Yes.
We use this equation for the data analysis of the experiment number 10. So today we are going to learn how we got this time period. That's what I told you. If you have the spring and the mass system, the last calculation is for the time period calculation. When you just have the simple pendulum, this will be the formula for the time period calculation. So what's the difference? Here I have square root of L over G, but what you have here? Square root of M over K. Here M is the mass, K is the spring constant. But here L is the length of the pendulum, G is the acceleration due to gravity. So if you have any question related with the spring with the mass or the simple pendulum, then you have to choose the formula, which formula is exactly suitable for that question. So by reading the question only, you can get the clear information. Understand? Understand? Now I am going to explain how to calculate this time period. My dear, what I am going to do, better I can just take this picture, I can paste it in the next slide. Better I can take this picture, I can paste it here. Now I'm going to explain here. My dear, listen carefully. Again, we are going to calculate this formula. What is our main formula? Could you please tell me the main formula? What is our formula? This is our main formula. We are going to we are going to learn how to get this formula. What is our equation? T, which is equal to 2 pi square root of L over G. So how we are going to get? See, so I am going to work out something here by using this diagram. My dear, when you place the bob, when you just attach the bob with the length of the spring, what will happen? It will be in the equilibrium condition, equilibrium position. Am I right? Now what I am going to do? I am going to extend the length of the bob to certain small angle theta. I said small angle. It's not a big angle. It's a small angle. And now when you just extend the bob to small angle, you have the free body diagram like this. This is my tension. This is my X component force. And this is my Y component force. This is my force due to gravity. Am I right? Am I right? Am I right or not?
Can you just repeat theta?
Yes, doctor.
My dear, when you just take this bob to small angle theta, these are all the forces acting on the string. If you have the length of the string, tension will be produced. And here, this is your force due to x component force, am I right? And this is my force due to y component. This is my acceleration due to, that means force due to the gravity. Am I right or not? We already studied the free body diagram in chapter number 5. Am I right?
Right.
Yes,
Now,
teacher, you
what
are right.
yes, now what I'm going to do, I am going to apply the torque rule here. We already studied the formula for the torque. Am I right? What is the formula for the torque, my dear? Could you please recall the formula? We already studied the torque formula in chapter number 10. What is the formula for the torque? Do you remember this formula? Torque tau, which is equal to RF sine theta. If theta becomes 90, then it becomes RF. Am I right?
Right.
Yes, teacher,
Now
you
I
are
am
right.
going to apply this rule for this diagram. My dear, when you just take the bob with a small angle, this is my length of the string. Am I right? This is my length. Am I right? Am I right or not?
Yes,
This is your
teacher.
length. So my length here is taken as my R. And what is the force? My force is this. Only in this direction the bob will be moving. So what is my force? My force is Fg sine theta. What is the angle between this R and F? 90 degree exactly. Am I right? So if I want to apply the torque rule for this pendulum, how I can write? I can write torque tau, which is equal to my R is L. So I can just write L, and my force is Fg sine theta. So I can just write Fg sine theta. The most important thing, the sine. My dear, if the bob will be moving in this direction, this is the sine direction, negative direction. Am I right? Am I right or not?
Right.
Yes,
You're
teacher,
right.
you
So
are right.
I can put negative here. Now I told you you have to take the angle, small angle. So I can just take, if my angle is small, if my angle is small, so my sine theta is approximately equal to theta. Am I right? So when you are just making the angle to small theta, so your sine theta becomes theta. So if you just replace the sine theta with theta, why? Because we are just displacing the bob of the pendulum to a small angle theta. So when you just make your sine theta to theta, your equation becomes tau, which is equal to minus L Fg theta. Am I right?
Yes, teacher, you are right.
Now what is Fg? What is Fg, my dear? My Fg, which is equal to m multiplied by g. Am I right? So I can take this, I can substitute here. So your torque tau becomes minus L mg theta. Am I right? Now I am going to compare this equation with the equation of the torque, because we have another equation for the torque. Torque tau is equal to I alpha. My torque tau is the torque, I is the moment of inertia, and alpha is the angular acceleration. So I am going to compare this equation with this equation. My left hand side of the two equations are exactly the torque. So I can equate this term with this term. So if I just equate, what I will get? I will get I alpha, which is equal to minus mgl theta. Am I right? Am I right?
Yep, teacher, you are right.
So now from this equation, I'm going to take the acceleration. So if I just bring the acceleration, I can take my acceleration here. I bring this I to the right hand side of the denominator. So what you will get? Minus mgl over I multiplied by theta. So now I'm going to move this term, this entire term to the left hand side. If you move this term to the entire left hand side, what you'll get? This negative becomes positive. So my angular acceleration plus mgl over I multiplied by theta, which is equal to 0. Am I right?
Yes, teacher, you are right.
Now, my dear, when the bob will be released, it will be producing simple harmonic motion. Just before we studied the simple harmonic motion, this is my simple harmonic standard equation. Am I right?
You're right.
Yes, teacher, you are right.
So this equation is for the linear. If you convert this equation in terms of rotational, how you will get, my dear? I can write this equation as d square theta over dt square plus omega square multiplied by theta, which is equal to 0. Both are exactly same. This is for the linear. This is for the rotational. Am I right?
Yes, teacher, you are right.
So I can take this equation for the calculation of this simple pendulum, because we are dealing with all the information, we are dealing with a rotational concept. So the standard equation for the simple harmonic motion is d square theta over dt square plus omega square theta, which is equal to 0. Now I am going to compare these two equations. My dear, listen carefully. Here I have an angular acceleration. Here, this is also your angular acceleration. And here I have mgl over I, and here I have omega square. Here I have theta. Here also I have theta. So these two equations are exactly same type. So what I am going to do, I am going to compare this omega square with this mgl over I. So brother, if you just see the pendulum, I have the moment of inertia for the length. Am I right? Yes, brother. Yes, my brother. Please ask your question.
No, sorry, doctor.
Okay, so I'm going to compare this omega square with this term. So what you will get, my brother? Omega square, which is equal to mgl over I. Brother, now what I'm going to do you remember that in chapter number 11 and 10, I told you the moment of inertia for the different structure formula will be given in your exam. Am I right? Moment of inertia for the solid sphere, moment of inertia for the cylinder, moment of inertia for the length. So we have the specified formula. So here, when you just see the length of the pendulum, moment of inertia for the length of the pendulum is given as I, which is equal to ml squared. So this is the formula for the moment of inertia for the length of the rod. So if any object is having the length, this is the moment of inertia. Now what I am going to do, I am going to take this formula, I am going to apply here. So what you will get, omega square, which is equal to mgl over ml square. Am I right? So this m and this m get cancelled, and here one l and another l will be cancelled. Finally you will get omega square, which is equal to g over l. Am I right?
Doctor.
Yes, teacher, you are right.
Yes. Yes, my dear.
For what we use this formula?
Because here we have here we have to replace this moment of inertia, because we are using the length. Am I right? This is only the length. Am I right?
Yes, right.
So
Yes.
if you have the length, the moment of inertia for the length like structure is ml square.
Oh, okay.
So I just replace this moment of inertia for the formula for the object which is having length like structure. So I just replace this formula as ml square. So m and get cancelled with m, and l get cancelled with l, and then finally I got omega square, which is equal to g over l. I'm going to take square root on both sides. So what I will get, omega, which is equal to square root of g over l. Am I right?
Yes, you're right.
Now we already know the formula, omega, which is equal to 2 pi over t. So I'm going to take this formula, I'm going to substitute here. If you substitute, what you will get, my friend? You will get 2 pi over t, which is equal to square root of g over l, and I am going to rearrange this equation in terms of t. Therefore my t, which is equal to 2 pi square root of l over g. Understand? So this is the equation we just got for the time period for the simple pendulum. Clear?
Clear. Doctor, this is the end of the equation, right?
Yes, this is the end of the chapter. This is the end of the equation for this topic. What, my friend?
Okay.
What, my friend?
Thank you, Doctor.
Could you please, my dear, listen carefully. You have two time period formula. The first time period formula is for the spring with mass. The second time period formula for the simple pendulum. So in the question, we will give the clear information about that. If the spring and mass will be given, use the previous formula. If the question is related with the spring, length of the string with the bob, then you have to use this formula. Clear? Clear?
Okay, clear.
Understand?
Thank you, Doctor.
Okay. Could you please recall the formula? How many formulas we studied in this chapter? Better we can just recall. What is the basic equation for the wave? Displacement of the equation, which is equal to xm cosine of omega t plus phi. My speed of the equation, that means velocity of the equation, is minus omega xm sine of omega t plus phi, and acceleration of this equation is given as minus omega square xm cosine of omega t plus phi, and then maximum speed equation v of p, which is equal to omega multiplied by xm, maximum acceleration which is equal to omega square xm. And what else we studied, my friend? We studied, what else we studied? We studied the time period. What is the formula for the time period for the spring with mass? The time period for the spring with mass is given as T, which is equal to 2 pi square root of m over k, and the time period for the simple pendulum T, which is equal to 2 pi square root of L over G, and then the most important thing, how to calculate the omega, which is equal to 2 pi f or 2 pi over T, frequency which is equal to 1 over T, and then based on the spring with mass, my omega which is equal to square root of k over m. Am I right? Am I right?
Yes, you are right.
And then here my omega which is equal to square root of L over, G over L. So when you are just having this formula, read the question carefully and then substitute. And what is the formula for energy? That's very, very important. What is the formula for energy equation, my dear? Half k xm square. So please don't forget. This is a very, very important formula. We have some question based on this. Clear?
Clear.
So these many formulas we have, my dear. It's my kind advice to each and everyone. I think here, let's just see the number of students. I don't know how many of you are here. Just a minute. Okay, here you have 21 students. You are here, my dear. Listen carefully. Especially the question from 14th and 15th chapter are direct question. Once you just read the question, you will understand everything very clearly. The only thing, you must know the formula and the equation. If you know the formula and equation, you have to write the equation, you have to substitute the value, you have to get the answer. That's it. Understand?
Understand.
So please, my dear, try to prepare well for the final exam, and the time is very short. Next week, inshallah, I will finish the numerical question from this chapter. So by that, we will complete the entire chapters of this physics one. So right now we are ready for writing the exam. Inshallah, by Sunday, our all chapters will be finished, including our chapter 15. And now it's a time for you to get the revision for the final exam. And inshallah, we have classes on 16th week also. My dear, classes on 16th week. If you need any revision, no problem. We can just go for that, because I will finish the lecture by next week. And one more week we have. Do you get my point? One more week we have. So in that time, if you have any doubts, please feel free to ask me, and I am here to help you. Okay?
Yes, teacher.
Okay, thank you, Doctor.
The second thing. Okay, my dear, let's I just come right now. Right now, 21 students you are here. Mr. I can just retell the names and the number. Mr. Ahmed. Sorry, wait a minute. 241. Ahmed is here. Ahmed Farid Al Rashidi.
Yes.
My dear, why you got 7.93 marks in lab 2 grade? Did you miss any experiment?
Which lab? One or the second?
My dear, first of all, listen carefully. We entered the lab 1 grade already in the SIS. Am I right?
Yes.
Now we are going to enter your lab 2 grade in the SIS. That means we take the average of the 6 experiments. We are going to enter the marks in the SIS. Okay?
Yes.
I got the mark. I think your doctor is Dr. Shivkumar. Am I right? I got the mark from Dr. Shivkumar. It's mentioned as 7.93. Why you got 7.93? What's the problem?
The first experiment.
Did you miss any experiment?
I will submit it, inshallah.
No. Listen first. Who is your teacher? Who is your lab teacher? What happened?
Doctor, I think the network is not good.
His connection is very bad, teacher.
Okay, connection issue. Okay, you
Yes,
can do
teacher.
one thing, my dear.
Yes, teacher.
Okay, Ahmed, please listen carefully. You got 7.93 in lab 2 grade. Okay.
Okay.
my question, did you miss any experiment for lab to grade?
What?
Did you miss any experiments?
No.
Then why you got 7.93? What's the reason?
In the second lab.
Yes, I'm talking about the second lab.
I don't know, teacher.
Okay, no problem. Listen, my dear, this message is for all. This message is for all the students. My dear, if you missed any experiments, both in lab 1 grade and lab 2 grade, because of any medical issue, you can take that experiment during your revision lab. Listen carefully. This is very, very important. My dear, you already lose more marks in the midterm exam. Try to get some marks from the lab also, okay? So it's my advice to each and everyone. If you missed any experiment both in lab 1 grade and lab 2 grade, you can take that experiment during your revision lab. But only one thing you have to do, please write the email to Dr. Saidur Rahman because he is our chairman. And please put the CC of my email as well as Dr. Arun Kumar email, okay? Because Dr. Arun Kumar is the course director of the physics group. And I am your class teacher. So when you are about to write the email to Dr. Saidur Rahman, please mention my email ID as well as Dr. Arun Kumar email ID and request that I missed this experiment because of this medical issue. So please kindly consider to do this experiment during the revision lab. Just request in a polite way and please send the email, okay?
Okay.
My dear, if you are in my section, no need to write because I already agreed the student. I already agreed the student, so we can talk with each other. Okay, so no need to write for myself. Those students you are in my lab section, no need to write. If you missed any experiment, no need to write the email. This message is for those students who are with other teacher. Clear?
Okay.
Clear.
So my dear, listen
Doctor,
carefully. Try to get some.
I have a
Try
question.
to get some marks. Yes, my dear.
Doctor, when I
Yes.
got when I get full mark in final lab, I will get
Okay.
60.43. This mean
Okay.
I am passed the physics, right?
Yes, you passed.
Yeah,
But my dear Abdullah, but don't forget to write the final exam. If the students they are forget to write the final exam, they will consider as failed. So be careful, eh?
Okay.
Because some students they said, Doctor, I already 60 mark. Why I have to write the final exam? Don't think like that. Appear for the final exam, okay? Understand?
Okay, doctor.
Okay, my dear, and one more student.
But
What's his name?
the most important part.
Try to get good marks, inshallah. If you have got 60 mark right now, means it's good. Try to get good marks in your final exam. Try to improve your grade. Okay,
Doctor,
Mr. Mr. Ahmad, again, the message is for you. Mr. Ahmad Jareed Al Rashidi and Abdul Mohsen. Brother, today is your retake exam. Don't forget, okay?
Okay.
And please inform Mr. Abdul Mohsen. I think he is not in the classroom. Please inform Mr. Abdul Mohsen. Your exam exactly started by 9:30 p.m.
Okay, inshallah.
Okay, Mr. Falah is here. Falah, Faleh, his name. His ID ends with 227. I think he's not here. Okay, no problem. My dear, it's my kind advice to all the students. Please log into your SIS and check your marks again and again. If there is any mistake, especially in the lab 1 grade and lab 2 grade, go to your concerned teacher, change the mark and ask your lab teacher to send the email to me. Because I am your class teacher, I can only enter the marks in the SIS. So those who are having the lab with other teacher, yes.
Dr. Siva Kumar is not
Okay.
give me a mark for lab work too. I don't know.
Okay, are you absent for any experiment?
He give me for 3 experiment, 7 and 8.
Why?
And
my dear,
9.
are you absent? That means you are absent for some experiments. Am I right?
No, I all the experiment I do it.
Okay, you can do one thing. Okay, you can do one thing. Write the email to the chairman. Okay.
Okay.
Okay, write the email. Listen carefully. Still, I didn't complete. Write the email to the chairman and put my email ID and Dr. Arun Kumar email ID as the CC. Okay?
Okay.
Because if you send the email, I can talk with them because I need the document.
I tell him last week in the lab.
No.
In the lab.
Listen, my dear, listen carefully. Forget about that. Send the email so that then it becomes official. Okay?
Okay, thank
Send
you.
the email, then it becomes official. I can talk with our chairman and I can talk with the course director. I can talk with your doctor.
Doctor, please talk with him about the grade. Sometimes you get all low grade, not 9.5. Sometimes
Okay, that's what, my dear, listen carefully. Whatever the things you want to write it clearly. Write it clearly in the email.
Okay, thank you.
Whatever you want to mention, just say in the polite way, and please write the email to Dr. Saidur Rahman. I think everybody knows Dr. Saidur Rahman email ID. Am I right?
Look.
Do you know Dr. Rahman email ID? Dr. Kumar email ID?
I have email.
Okay, no problem. You are in my group, am I right? I can just send the email ID of the teachers. You can just write the email quickly. Otherwise, time is very short.
Yes, okay, thank you.
Time is very short, my dear.
I have
Those who want to...
Tomorrow I have a class in the in Doctor.
Dr. Shivakumar, huh?
Yes.
Okay, do one thing. Send the email today itself, now itself.
Yes, okay. Thank you.
Otherwise tomorrow you will not be able to do. Better write the email and put the email ID of my ID and as well as Dr. Arun Kumar ID. And please write the email to Dr. Saidur Rahman.
Okay, thank you.
Yes, Khalid. What's your question? Yes, my dear, please ask your question. I'm hearing you, please.
Doctor, what does it mean, XM?
Amplitude. XM is the amplitude. Clear? XM, I can just show you here. Your XM is the amplitude, okay?
Okay.
Okay, my dear. I think our class is over today. Okay, doctor, when you submit the lab work marker, my dear, inshallah, today or tomorrow, you can see your lab 2 grade in the SIS, okay? Because I am receiving the marks from other teacher, I am going to enter the marks together, okay? So maybe today or tomorrow, you can see your lab 2 grade. Yes, Mr. Khalid, could you please talk to me?
Doctor.
Yes, I'm hearing you, please.
Tomorrow revision lab, right?
Yes, tomorrow is the revision lab.
And next week we have final lab.
You have final lab exam. Inshallah, when you come for the revision lab, I will give the instructions, okay?
Okay, thank you, doctor.
Okay, that's it. Mr. Khalid, if your mic is not working, could you please type? I can just read and give the answer. Okay.
Doctor, are you here?
Yes, I'm here.
Okay.
I called my name. Just a minute.
Teacher, you said his name in the first class, in the beginning.
No. That is Khalid Muhammad 922. His name is Khalid Ali Asri. My dear Khalid Ali Asri, I'm not calling you. One more Khalid is in my section.
We thought you mean Khalid al-Asiri, so we... We
No,
told
no,
him.
no, it's not not Khalid Al-Yasri. His name is Khalid Muhammad Al-Ghahtani.
Mm.
Okay, my dear. So please prepare well for the final exam. Inshallah. See you on next class. Yes, my dear.
Ahmed, he talked with me. He missed one experiment.
Okay.
When he said when he will do, he can
When
come
when he has
tomorrow.
when he has the class.
I think he missed it. He
I
he
think
have class.
who is his doctor?
Saif Kumar, Ahmed Giradi.
My dear, listen carefully. That's what I told. Ask Mr. Ahmed to send the email to Dr. Said Rahman immediately.
And tomorrow he come because tomorrow the deadline, right?
That's what I said. Tomorrow is because next week some students you are going to write the final exam. So please
Yes, yes.
try to write the email. Try to inform him to write the email quickly. Okay? And please mention my email ID and Dr. Arun Kumar email ID. Inshallah, after the class, I will send the email ID of the doctors through WhatsApp group. Okay?
Okay.
Okay. So don't forget, my dear. Otherwise, I can't help you. If you are having the valid reason, we will allow the student to do the experiment.
Okay.
Okay.
Thank
Okay,
you.
my dear. See you. See you. Please inform him. Okay?
See you, inshallah.
See you, brother. Assalamu alaikum.